than 70 by 210. Exactly 70 by 210, that is the not the answer because it is distance by speed, not speed by distance. So the third option is 210 divided by 70. Exactly, that is the answer because we are talking about the speed, and speed is given in terms of distance by time, and this is nothing but the distance which is the actual path traveled. And more than 210, that is also not possible. So option number C is the answer. Now we will see the structure problems. Now we will see the structure problems in motion. So you can see here question number 1. A solid plastic sphere falls towards the earth, and figure 1.1 is the speed time graph of the fall to the point where the sphere hits the earth's surface. And question number 1 is that describe in detail the motion of the sphere shown by the graph. So you can see this is the graph, and the x-axis is the time axis, y-axis is nothing but the speed. The graph is, you can see the speed is increasing here, then it is slowly increasing, and at last it is becoming constant. So we had already seen this kind of slide in while learning the motion chapter. The speed time graph, if we have the speed time graph, then the slope is nothing but change in y-axis divided by change in x-axis. That's nothing but, here in this case, the change in y-axis speed, change in x-axis is nothing but time. So slope is nothing but change in the velocity divided by change in the time. That is nothing but the acceleration. Okay, so the slope of the speed time graph is nothing but the acceleration. And we have seen the different cases for the different speed and the acceleration. You can see here the speed line is coinciding with the time axis, and that's why the acceleration is 0. For this case, the speed is increasing and acceleration is constant because this is a straight line. And here this is horizontal line, so speed is constant, the acceleration is 0. Here the speed is decreasing, acceleration is negative constant because it is again the straight line. And in MCQ 1 we had already seen for the steeper line slope is of course more, and for that acceleration is also more. So here you can see between P and Q the speed is increasing, and it is almost like a straight line, and that's why the speed is increasing. So we can say the slope is also there. We can see the constant kind of slope is there. So acceleration is there. We can say even if you consider this approximately the straight line, we can consider that the acceleration is there because the speed is increasing. Here between Q and R, you can see the rate of increasing speed is decreasing. It is increasing, but slowly it is increasing. Here it is increasing rapidly. Okay? So when it is increasing slowly, we can say the acceleration is decreasing. The acceleration is decreasing over here because you can consider this is a steeper line. We can consider this is less steep. Okay? And here the speed is constant, so acceleration will be equal to 0. So from the horizontal line, we can say the acceleration is nothing but 0. So it is we can say this is like the steepest line. Here the line becomes less steep. This is not a line, this is the curvature. We can see the curvature becoming less steep. So the acceleration is also decreasing here. It becomes 0. So we can write down step by step. First of all, we will write down over here. We can write down initially acceleration is there as speed is increasing. Okay, initially there is acceleration because speed is increasing. Okay, here you can see this is we are talking about from P to Q. Then here we can say the acceleration is getting less than acceleration is getting less. Okay, that could be our second point. This question is of 3 points. We should at least write the 3 points. And third point, you can say the speed with speed as you can write as with speed. Speed is becoming constant. The acceleration, in that case you can write down acceleration is 0. For the horizontal line, the acceleration is nothing but 0 because slope is nothing but 0. Okay, so at least 3 points you should write for 3-mark question. So I hope you have got this question. Now the part B of the question. Here you can see on the figure 1.2, draw arrows to show the directions of the forces acting on the sphere when it is at the position shown by point S on the graph. Label your arrows with the names of the forces. So where is the point S on the graph? So this is the point S, you can see here, and where the speed is nothing but constant. So why the speed is constant? There must be two forces, there must be forces which are acting on an object which where resultant should be equal to 0. That's why only the acceleration is 0 and the speed is constant. So which two forces are acting on the sphere? We know that when the body is falling freely under gravity or in the air, we know the two forces are acting, which are nothing but the gravitational force, and second one is the air resistance. We had learned this while learning the terminal velocity. Okay. So first of all, I will show over here the gravitational force which is acting in the downward direction like this, and there must be the air resistance which should be acting in the upward direction, and we should show these two lines to be equal. Here I have shown this to be equal. This is the arrow for the air resistance, this one will be the arrow for the gravitational force. Okay, this should be equal and opposite because the resultant should be equal to 0, and in that case only we can get the constant velocity. So here you have to label, here it is nothing but the gravitational force, and this one is nothing but the air resistance. This is the air resistance. Always remember this length of the arrow should be equal because they should be equal and opposite, so that they will cancel each other and we will get the constant velocity at point S. Also, this the gravitational force should act from the center because we always draw gravitational force to be acting from the center of the mass. I am considering this as the center of mass. Though gravitational force acts on all the points of the object, but if you want to draw the single line, single vector, you have to draw it from the center, assuming that this is the center of mass. But the air resistance does not act through the center of mass, it acts on the surface. So here I am showing this arrow from the surface. Now explain why the sphere is moving with the constant speed at particular point, that is nothing moving as. So what is happening basically over here, the as the object is moving down, the gravitational force is actually initially it is greater than the air resistance, but as it moves down, what happens, the air resistance increases continuously, and at particular point, that is nothing but point S. At this point, the gravitational force and air resistance are equal and opposite. That's why it is moving with the constant speed. So we can write down over here, when the gravitational force is equal to the air resistance, the resultant force that is the total force. The resultant force is 0, and the speed becomes constant. In this way, we can write down when they are equal, the speed becomes constant, and we can write down the acceleration is nothing but 0. So that means when the speed becomes constant, the acceleration